All right, so still we are on alkenes, and in this one we are going to be drawing the structures for the compounds that are given to us. So the first one is 2-chloro-3-methyl hex 1-ene. So hex 1-ene means that I have 6 carbons, of course. So 1, 2, 3, 4, 5, 6. Okay, and then 1-ene tells me that my double bond is between 1 and 2 carbons. Then 1, 2, 3-methyl, 2 chloro. Okay, and that's about it. Okay, for this structure, not too complicated. Let's go on to the next one, 1-methyl cyclohexene. Okay, so this is a cyclic compound. Now you will not believe this, but it's actually true that a lot of people don't really see the cyclo. So many times I've seen this is that I'll give them the cyclo there and somehow it just disappears and I end up getting a straight chain, okay, for this. So in any case, cyclohexene means that I have a double bond in the 6-membered ring and it says 1-methyl. So which means that I can do this. I can also do this. Same thing, okay, because when you have a cyclic compound, you can start the numbering from wherever. Now, you might think, I don't know if you're thinking that way or not, is the 1 an overkill, okay, over here? Because regardless of whether we have this structure or this structure, is pretty much the same thing. And if I didn't write the 1, where does the methyl group go? Which means that the methyl group should technically go to where the double bond is starting from, okay? So generally that's how it is. So that 1 is a little bit of an overkill, and sometimes, you know, when the rules are not very clear, you can do that. And no, I don't take off points if you do all that stuff, okay? I might just circle it, but I don't take off points for that. In any case, especially not in this one. All right, so let's go on to the next one. And now we have E2-hexene. And so now it means I have to decide for the E and Z. So E, remember, is going to be on the opposite side. So the first thing I want to do is I just want to go ahead and write the structure out, okay? So again, 1, 2, 3, 4, 5, 6. Okay, and I have 2-hexene, which is this. So now E tells me that my higher priority groups are on the opposite sides. Okay, so opposite side, which means actually I have the right structure. But just to make sure, I'm going to go ahead and write my hydrogens. And so my hydrogens are on the opposite sides, which means my higher priority groups now, the carbon and carbon, they're on opposite sides. So this is actually the fine structure. This is okay. So E generally, when you don't have any other group, okay, can also stand for trans. So it depends, okay? So if you have both hydrogens on the double bond, then you can use cis and trans also, okay? But E and Z is really the absolute, okay? The best way to write configurations. Okay, now let's look at the last one over here. And for the last one, here we have a huge structure, 1 bromo, 1 chloro, 2-methyl hex 1-ene. Okay, so again, hex 1-ene, so which means 1, 2, 3, 4, 5, 6. And let's see, draw the structure out first, okay, and then we'll go from there. So here is the 1. On 1, I also have chlorine. On 1, I also have bromine. And then I have a methyl group on the second carbon. So 1, 2, 3, 4, 5, 6. So everything else is correct now. All I need to figure out is if my E is correct or not. And A and E again is the opposite side for higher priority groups. Okay, so I have to figure out what my higher priority groups are. So I'll go ahead and slice my double bond down here. And when I slice it down, bromine is the higher priority between chlorine and bromine because bromine is higher atomic number. And then between a methyl group and a CH2 that's connected to all of this carbon is going to have higher priority. So obviously my structure is a little bit wrong. So I have to switch bromine with chlorine, okay, on that side. And remember, the reason you have E and Z for double bonds is because double bonds do not rotate. Okay, so they are stuck in their rotation, and because they are stuck in their rotation, the location of all the other groups is also stuck on there. Okay, so here is my structure. Now I'm going to switch out bromine with chlorine. Okay, so that's the right structure. So now I have my higher priority groups on the opposite side. Okay, so that's the E structure now.